Hello, I'm Marty with UltraSafe, and today we're going to go over a few fall protection scenarios. Pretty basic. Every time we put one on, we want to look at the harness. We want to inspect for rips, tears, burns. We want to see that there's no distortion in the hardware. Everything on a full body harness that is load bearing is done in an opposing color thread. So I have black webbing here, I have white thread. That's my main focus point on the stitch patterns. If it's a pad or tool belt, it's not load bearing. We want it to look cool. It'll probably be black material on black thread. But if it's opposing color, that's the first thing that we're going to inspect. We want to look for any buckles that don't work properly, that don't latch properly, or that they're distorted, or may have rust or other chemicals on them. By the way, harnesses are machine washable. Sometimes, they get, sweaty or dirty. They can be put in a shoe bag, dropped in the washer, light detergent. They have grease on them, which I don't think you're going to have this environment. You put a little Dawn in it, but not too much. And then take them out and let them dry naturally. Don't throw them in the dryer, you'll ruin them. Again, I'm looking for rips, tears, burns, distortion in the hardware. So far, everything looks fine. Let's take a close-up of the harness. I mentioned one of the things we want to look at is we want to make sure that the buckles work properly, that we don't have an excessive amount of rust or wear and tear, any distortion, to make sure that they're working properly. Number two, I mentioned that anything on a full body harness that is load bearing is done in an opposing color thread. So here's the parts that we want to start looking at as far as ripped threads, things like that. That is going to be more critical than something like a tool belt, which you won't really have on this facility, or if you have any pads on a harness. Those are really not load bearing and that critical. We want to look at distortion on the D-ring. If we saw that this was distorted somehow, it means somebody tried to tow a forklift with it, or they used it for something they shouldn't have done. That would be criteria for pulling it out of service. But most important is we want to know who manufactured it and when. And all of these come with a serial number, which management will have documentation of when they come onto the property. They have the inspection tags on them. Gives you kind of a quick thing to go over, but it's always best to refer to the manufacturer's instructions, which come with the harness. In this facility, we're using retractable lanyards. It's pretty much tie off or die off. Retractables. They work on centrifugal force at about 4.5 feet a second. There's some brake pads that fly out into the housing and catch. Now, a lot of people think that's where it stops. This happens to be a Class B retractable, which means that it has a mechanical shock absorber inside the unit. So in a drop, instead of just stopping, a disc brake inside here allows the drum to turn and decelerate, taking, maybe a 2,000-pound hit down to about less than 500-pound hit as far as the free fall is concerned. That's your deceleration or your shock absorbing capability. This retractable happens to be approved for free falls at foot level, but at this facility, most of your tie-off points will be above head, so that won't be an issue. Now, when we're inspecting our retractable, it's more critical than a wire rope sling or a nylon sling. In wire rope slings, as far as reading is concerned, we allow so many broken wires. In retractables, we allow no broken wires. When we do our inspection criteria, each time before use, we should inspect the wire or web like we would a wire rope sling or nylon sling. It's a more critical pick. We're talking personnel. We want to make sure that our flywheel is working properly by giving it a couple tugs. We want to make sure that the hardware is working properly. This happens to be a roll gate, that it opens and closes properly. These retractables have a load indicator hook. When someone takes a free fall on one of these, it shears this pin here and you'll see a red ring. That means that it needs to be pulled out of service, red tagged. This particular retractable can be reserviced, recertified. They're not throwaways. It's about half the cost of a new one. We also want to make sure that we can read the manufacturer and that we can read what it's rated for. These are all important points before we put this thing in use. Sometimes glue, concrete, and other debris can get sucked up into these mechanisms and allowing the freewheel just to keep going. And sometimes it can be a long way down. So let's take a close look at the retractable. First of all, we know who the manufacturer is. We know that it's a Class B retractable. It'd be approved for over-the-edge drops or foot-level drops, but that won't be really a situation in this facility. We're going to inspect the cable to make sure that there's no broken wires. It's normally best to pull it all the way out. We don't want to take the harness retractable and let it snap. A lot of times what you can do is you can lock up the retractable. If you let it fly into itself, all you have to do is collapse the spring, bring the brake pads back together, and she's loose again. So if you do have this situation, it doesn't mean you have to send it back to the factory. It just means you need to collapse those springs again. We want to look at the hooks in both ends to make sure they're in proper working order. We don't have any cracks or distortion. That gate closes properly. Again, we brought up the load indicator hook. This is a shear pin. It shears at about 450 pounds. This hook will drop down, you'll see a red ring. Again, it doesn't mean the retractable will not work, but it means it needs to be sent back into maintenance. So we want to red tag this, give it to our supervisor so it can be sent in for maintenance. We want to make sure that the swivel is working properly up top. If it's binding up, there's a good chance there's some distortion in the hardware. Same thing with the other connection. Make sure it's working properly. A lot of people, when they put a harness on, they just take it out of the bag. Believe it or not, they do come with instructions on how to adjust them properly. Those normally wind up down there somewhere. The best way, when we first take the harness, let's make sure it's adjusted to our body size, not the person before, because the only time we're really going to have to use this thing is really in a fall. And we want to pick the harness up by the back D-ring. What these things basically are like four-leg bridles. We want to make sure that all the pick points are even on the front and back. Sometimes when you get these out of the bag, you may notice that this is adjusted up a lot higher on one side. It may feel fine when it's on, but when you take a drop, it's going to be a side impact to your spinal cord. So we want that spinal cord to take an even hit. So this D-ring slider, we can adjust the material so that's even. We want to look at our torso adjustments. Make sure that they're even on both sides. I see on job sites all the time, someone may have it 6 inches higher on this side, 6 inches lower on the other. Feels fine when it's on until you take a drop. These are pretty much just like putting on a coat or anything else. First thing when we put these things on is we want to look at the chest strap. That's pretty much what it means. It's a chest strap. We don't want it down by our belly. Not at this facility, but out in the field, like iron workers who may be tied off at their feet. When they take a drop, if it's down by their belly, sometimes they can pass right through the harness and slip out of it. We don't want it up at our neck, even if we have it adjusted properly, because in a drop, everything comes up abruptly. There's been 2 reportables in the industry over things like ballpoint pins being in the pocket. If the leg straps are not adjusted properly, you can imagine in a drop, as these leg straps come up, this chest strap comes up very violently and very quickly. One gentleman had pulled the pin out of the pocket and jammed it through his jugular. He bled out. Another guy, he had the leg straps down by his legs, chest strap where it should be. As it came up, a steel pin actually just pierced right through his chest plate, killed him instantly. So let's make sure we have the chest strap right. Now that I have my chest strap pretty much where I want it, I want to make sure the leg straps are hooked up properly so I don't have everything come up on me immediately. When we're putting these things on, one size does not always fit all, but these are extremely adjustable. These have torso adjustments. So, if people are afraid that, they need to put these things on like a tourniquet, that's not really necessary. If you're walking around with a harness like this all day long, it's uncomfortable, it's going to fatigue you out. Every time you bend down, it's going to be pulling against you. So if you have a situation like this, we can lengthen the torso adjustment and get these leg straps more horizontal to the ground. You can see now my leg straps are a little loose, so I'm going to tighten them up just a little bit on both sides. We take the quick release buckle, we turn it at 90 degrees, and we just move a little bit of material. We want to make sure we have it the same on both sides. Again, keeping that impact even to the spinal cord. Now I'm pretty comfortable. First thing I want to do too is I want to come down can see that the thing moves with me, not against me. This feels pretty comfortable to me. I look in the back, the D-ring should be between my shoulder blades, not up against my neck. If it's up against my neck, it's going to be uncomfortable. I can take that D-ring slider, adjust it between my shoulder blades, make sure all the pick points are even, and put it on again. When I go out in the field, a lot of times people like to see a live drop. And if you take a 220-pound piece of steel and it hits the ground, it's a different impact than a 220-pound person hitting the ground. That's why when I use this 220-pound rigid test weight, it really represents a 310-pound person. You'll notice that a lot of harnesses are rated for 310 because when a person hits the ground, their vertebrae is compressed, organs slosh around. We're kind of made a silly putty versus a piece of steel is going to keep going. The impact's much greater. So let's take a look at this drop. So what we have here is we have our retractable lanyard hooked up overhead, and we have a 220-pound rigid test weight. And what I want to show here is how the retractable just doesn't stop, but how it decelerates. And that's the shock absorbing capability. That's why on these retractables, we also don't want to put another shock absorber on them. Sometimes when that shock pack releases, like a synthetic shock absorber, it can disengage the flywheel of this and cause like a ratcheting effect. So make sure there's nothing between you and that tie-off point of that retractable. If you have a cross-arm strap or a D-ring extender, there's nothing there that's going to take any weight off the flywheel. So you notice when we did those drops, they were with web retractables. You may not have a lot of call for that at this facility. But when these deploy, you notice how the disc brake kicks in right away. But there was also some deceleration, deployment of that disc brake mechanism or mechanical shock absorber. We have to allow that for lower level contact. It deployed only about 12 inches since it was completely overhead, but these can deploy up to 30 inches, so we always want to keep that in mind as lower level contact. Also, the web retractables have a different load indicator on them. They'll have what's called a rip stitch. They'll be sewn here, and it'll bust the threads at approximately 450-pound impact. If you saw that on a nylon sling, you'd pull it out of service. If you see it on a retractable, you pull it out of service. The inspection criteria is similar to the wire rope. We want to inspect the web for rips, tears, burns, any defects, and we can always pull it out of service and have it re-webbed. This is what one of the units look like before it's been deployed. When we're ready to engage our retractable, remember tie off or die off. The harness doesn't do you any good by itself. These are roll gates. A lot of times they can be operated by one hand by spinning it and opening it. We want it in the open position. We want to make sure we don't get our thumb caught between the D-ring and the hook when we put it on. I'll properly engage. Now I can do my work. The retractable follows overhead. If I take a drop, keep in mind that that mechanical shock absorber will deploy a little bit, so we want to allow a little bit of room underneath this for lower level contact. When I'm done using the unit, I want to make sure that I don't let it just fly up into the unit, or I'll lock the unit up and I'll eventually damage it. So here we have a close-up of our load indicator hook. You can see the shear pin here in case we do take a drop. This is a roll gate. It's good for a side load if that does happen, good for 3,600 pounds. Pretty much can be opened with one hand. We want to make sure that we don't get our fingers up into this, or you can sometimes get your hand caught between the D-ring and the hook. Now that I have the hook in the open position, I'm simply going to reach back, hook it in my D-ring, and I'm ready for work. Now that I'm done with my work, and I'm on the ground, I feel more comfortable, we just reverse the process. We spin the hook open, detach it. One thing we want to make sure that we don't do when we're done with it is just let it fly up into the unit, because that will make the brake balls fly out and you'll lock up the retractable. Again, if you do that, all you have to do is compress the two blue caps and they'll release. But it's best if you can take it up to the unit and release it gently. There you can see I successfully attached and detached to the system, did the job that was necessary. Let's say I didn't and I had a fall. Out of the 15 fatalities I had, one was counted as a suspension trauma death. And what can happen in full body harnesses, especially if you don't have them fitted properly is when you're suspended from one, we have large blood vessels that run through our legs, and these can act as tourniquets. And in 2001, I had a gentleman that took a drop, and he was up there for 10 or 15 minutes. They got him to the ground. They clipped both leg straps off. He took 2 steps and dropped dead. And what had happened is the blood in his legs had pooled and died, rushed up into his torso, and it killed him. Back in 2001, they really didn't know a lot about suspension trauma, but what probably would have saved the person's life is if they would have got him down in a seated position with their legs out. Instead of clipping both legs at the same time, unhook one leg. Let the blood flow up through their torso, through their kidneys, through their liver, maybe for 5 minutes. 5 minutes later, clip off the other one. Let him do it for another 5 minutes. Let that toxicity get out of his system. We don't know how long he's been in that position. Maybe let him sit for 5 more minutes, give him a little water, get him up in a chair. Or where suspension trauma death happens is after we get the person down, we clip the leg straps off and release the 2 tourniquets at once. So make sure you have a plan. Now that I've finished the job, I survived my suspension trauma death, what do we do with the product when we're done with it? Well, the way we put it on, we just reverse the process. I'm going to unhook my leg straps. I'm going to unhook my chest strap. And then when I'm done with it, am I just going to leave it on the floor? No, actually what we want to do with these is we want to store them in a cool, dark place, away from moisture, away from heat. We know here we're working in an indoor environment, but they are subject to UV ray. You know, we don't want to throw them in the back of a pickup truck. Sunlight can make them deteriorate. As far as the maintenance that you could do here, occasionally if you wanted to machine wash the harnesses, you have the manufacturer's permission. Any modifications on the harness itself, that must be done at the factory, or you pretty much void the warranty. As far as your regular maintenance on your retractors, if you occasionally want to, you don't really have a greasy environment here, but if you occasionally want to wipe them down so they're easy to inspect, that's fine. But as far as opening one of these up on your facility, that should strictly be done at my facility. So if you have any issues with this retractable, it should be red tagged and sent back to the manufacturer. I'm constantly also asked if these have a shelf life or a service life. And there is an ANSI reg that was written by a manufacturer, probably to sell more harnesses, that they have a 5-year shelf life or a service life. But you have to refer to the manufacturer's recommendations first, which would override that. Most manufacturers will say that you must inspect before use. They would like to have a minimum of an annual inspection, written by a competent person, that they be proper working order. And as far as the lifespan, it could be forever. The same thing would be with retractables. Some manufacturers say that you have to send them in once a year for recertification. Again, checking with this particular manufacturer after they pass inspection, inspected, written by a competent person once a year, they can pretty much have an indefinite service life. I mentioned earlier in the video that I've been doing this since the early 80s, and I have seen a lot of atrocious fatalities and maiming. This is another tool you're given that can make your job easier. It can either save your life or end it. So it's important that you be aware of your surroundings and also be aware of each other, because this product here could save your life or a life of your coworker.